When people think about the greatest challenges faced during the global war that reshaped the modern world, their minds usually go straight to massive battles, advanced weapons, or brilliant generals standing over maps. But sometimes, history pivots on something quieter, something hidden in plain sight. And sometimes, the person who changes everything isn't a soldier, a scientist in uniform, or a military leader at all. Instead, she might be someone the world never expected to shape the future of warfare, communication, and technology. This is the story of a woman whose life looked like it belonged on a movie screen. Because it did. Yet behind the glamour, the spotlight, and the fame, she quietly helped solve one of the most dangerous technical problems facing Allied forces during one of humanity's darkest chapters. Her name was Hedy Lamarr. At first glance, nothing about her early life suggested she would play a role in solving a major wartime challenge. Born in Europe, she grew up surrounded by culture, art, and intellectual curiosity. Her father, according to available accounts, encouraged her fascination with how things worked. He would explain the mechanics of machines, the patterns of systems, and the invisible forces that made everyday inventions possible. Those moments sparked something powerful in her, imagination, but the world didn't immediately see her as a future innovator. Instead, it saw her as a rising star. As she grew older, her striking presence and charisma drew attention from filmmakers. She quickly became known for her acting talent and captivating screen presence. Audiences were mesmerized. Producers were eager. The entertainment industry welcomed her with open arms. Yet beneath the glamorous surface, Lamarr was deeply curious and intensely observant. She spent time studying engineering concepts and experimenting with ideas, often during breaks from filming. While many around her viewed her primarily as a celebrity, she viewed herself as someone constantly learning, constantly thinking, and constantly imagining solutions to complex problems. Her personal life would unexpectedly expose her to the inner workings of military technology. During a period when she was connected to influential individuals involved in defense manufacturing, she reportedly overheard conversations about weapon systems and communication vulnerabilities. These discussions, according to historical accounts, left a lasting impression on her. She began to understand that modern warfare depended heavily on secure and reliable communication. When the global conflict escalated and spread across continents and oceans, one particular problem began to haunt Allied forces. Torpedoes, which were essential for naval strategy, often relied on radio signals for guidance. In theory, this allowed operators to direct weapons toward moving targets with greater precision. But in practice, there was a devastating flaw. Enemy forces could intercept or disrupt those signals. By jamming the radio frequencies, they could cause torpedoes to lose guidance, veer off course, or become completely ineffective. This meant that an advanced weapon could be rendered useless by electronic interference. For military planners, this was more than an inconvenience. It was a strategic vulnerability that threatened naval operations and endangered countless lives. Engineers and military experts searched for ways to solve the problem, but it proved incredibly complex. Radio signals were predictable. Once an enemy identified the frequency being used, it became easier to block or manipulate it. The challenge was finding a way to make communication secure, flexible, and resistant to interference without sacrificing reliability. While experts wrestled with this issue, Lamarr found herself thinking about it from a completely different angle. She believed that if a signal could constantly change in a synchronized pattern between the transmitter and receiver, it would become extremely difficult for anyone to track or jam it. The idea was elegant in its simplicity but incredibly advanced for its time. Lamarr didn't develop the concept alone. She collaborated with composer and inventor George Antheil. His experience with synchronized musical instruments gave him insight into how coordinated patterns could operate across separate devices. Together, they explored the possibility of creating a system where communication signals would rapidly shift between different frequencies in perfect harmony. Their concept became known as frequency hopping. Instead of sending a signal through a single predictable channel, the system would jump across multiple frequencies in a coordinated sequence. If an enemy tried to interfere, they would struggle to predict where the signal would appear next. The communication would remain intact, while interference would become far less effective. The idea was groundbreaking. It offered a potential solution to one of the most pressing technical challenges of wartime communication. Lamar and Antheil worked tirelessly to refine the concept, eventually securing a patent for their invention. According to available historical documentation, their design used a mechanism inspired by player pianos to synchronize frequency changes between transmitter and receiver. But despite the innovation, the response from military authorities was complicated. Some officials reportedly struggled to see how the invention could be implemented effectively using the technology available at the time. Others, according to historical interpretations, may have underestimated Lamar's technical contributions because of her status as an actress rather than a traditional engineer. As a result, the invention was not immediately adopted for active wartime use. Lamar was encouraged to contribute to the war effort in other ways, including supporting fundraising campaigns and boosting morale. She did so enthusiastically, understanding the importance of unity and support during a global crisis. For a while, it seemed as though her technical breakthrough might fade into obscurity. Yet the story didn't end there. As technology advanced over the following decades, engineers revisited the concept of frequency hopping. With improvements in electronics and signal processing, the idea suddenly became not only practical but revolutionary. Modern communication systems began to rely on variations of this very concept. Secure military communication, satellite transmissions, wireless networking, and mobile connectivity all benefited from technologies that evolved from the foundation Lamar helped create. Her work quietly influenced the way information travels across the world, shaping everyday tools that billions of people now rely on. Pause for a moment and consider that. An idea developed by someone widely known for her acting career helped lay the groundwork for communication systems that connect entire continents. It's the kind of hidden legacy that challenges assumptions about innovation, talent, and who gets remembered in history. But here's where the story takes an even deeper emotional turn. For many years, Lamar's contributions remained largely unrecognized. She continued her career in entertainment, appearing in films and maintaining her public image, while her technical achievements stayed in the background. Public awareness of her invention grew slowly, often through researchers and historians who uncovered the full extent of her work. As recognition finally began to emerge later in her life, it sparked conversations about how history sometimes overlooks individuals whose achievements don't fit traditional expectations. Lamar's story became a powerful reminder that innovation often comes from unexpected places, and that creativity can bridge the worlds of art, science, and technology in extraordinary ways. Her journey also reflects a broader theme about perception. Throughout her life, she was frequently celebrated for her appearance and screen presence. Yet those qualities overshadowed her intellectual curiosity and engineering insight. According to interviews and historical accounts, Lamar expressed frustration that her inventive mind was often underestimated. Still, she never stopped exploring ideas. She remained fascinated by science and invention, continuing to develop concepts and experiment privately. That persistent curiosity became one of her defining characteristics. Even when recognition arrived slowly, Historians now view her work as part of a larger evolution in communication security. Frequency hopping and related technologies became essential tools in preventing signal interference, protecting sensitive information, and enabling reliable wireless communication across vast distances. The ripple effects of her contribution continue to expand, influencing technologies that support navigation systems, emergency services, and global connectivity. What makes Lamar's story especially compelling is how it challenges the narrative of who gets to shape history. Innovation isn't limited to laboratories, military command centers, or academic institutions. Sometimes, it emerges from individuals who simply refuse to stop asking questions. Individuals who notice patterns others overlook. Individuals who combine creativity with determination underscore toggle and reshape the future in ways that are only fully understood years later. There is also something deeply human about her journey. She experienced fame, public scrutiny, personal challenges, and the constant pressure of living under the spotlight. Yet she managed to nurture a private world of intellectual exploration. That dual identity, balancing artistry and scientific curiosity, remains one of the most fascinating aspects of her legacy. Thanks for watching. And until next time, keep exploring the stories that history almost forgot.